Air-cooled condensing system consists of three main sections, which are the air-cooled condenser, also known as ACC, auxiliary system, and a fully automated control system. And ACC consists of the support structure system, air moving system, feed tube bundle system, and a steam distribution system. Air-cooled condenser. During normal operation, the exhaust steam from the exit of the cylinder of the turbine enters the steam header through its main steam duct and distribution manifold, and then enters the tube bundles. There are basically two types of fin tubes. One is aluminum fins with round base tubes of large diameter, aka multi-row fin tubes, and the other is the flat steel tube with aluminum fin embraced outside on top of base tubes, aka single-row fin tubes. When the steam reaches the tube bundle, heat transfer occurs between the steam and the air generated by the rotating fan, condensing the steam into condensate. The tube bundle consists of first stage forward flow and second stage counter-flow bundles. Firstly, the steam passes through the first stage bundles, resulting in from 70% to 80% of the steam cooled down and condensed into condensates, which will then flow into the condensate collecting manifold and lastly into condensate tank. The remaining from 20% to 30% of the steam enters the second stage bundles and is condensed into condensate before entering the condensate collecting manifold and then into the condensate tank. The steam residual that is non-condensable is removed through the vent hole located at the top of the second stage bundle by using the air removal system in order to maintain the system in vacuum condition. Auxiliary system for ACC. Auxiliary system comprises an air removal system, condensate system or steam exhaust device system, drainage system, bypass system, cleaning system, louver system, water misting spray system during peak load, and so on. There are basically two types of steam exhaust device system. One is two-stage air ejector, and the other one is the water ring vacuum pump. If the two-stage steam ejector is used, the water condensate will pass through the condensate pump and will firstly transport it to the ejector condenser to serve as a cooling medium, after which a part of the condensate will pass through the circulation valve and return to the condensate tank for use in adjusting the water level in the tank. The remaining condensate will pass through a discharge valve into the deaerator and then further into the boiler, ready for the next round of thermal cycling. The low-pressure drainage from the steam turbine passes through the drainage expansion tank, flashing into the drainage system. When the steam passes the exhaust pipe, a portion of steam condenses into water, which also enters the drainage system. Under the action of gravity, all drainage flow into the condensate system or steam exhaust device. ACC is surrounded by the wide wall to prevent undesirable hot air circulation and adverse wind condition. Air-cooled condensing system has operation accessories like the bypass system, louver system, and other auxiliary systems to ensure the anti-freezing performance during winter. There are also options for automatic or manual clean system for regular clean of the tube bundle to ensure the heat transfer performance of the entire system. Other optional items like water misting spray system, which is used for cooling during peak load in the summer for improving the system economically. For use of maintenance and access for inspection and repairs, there is also an option to install an elevator to facilitate the work. Automated control system. The main steam duct is fitted with pressure and temperature transmitters to monitor the parameters of the exhaust gas from the steam turbine. Water collecting and gas exhaust pipes are installed with a temperature transmitter, used for the monitoring the temperature of the condensate and non-condensable gas. The condensate tank or vent is equipped with a liquid level detection device, used for regulating the valve opening, and the start spots of the pump by controlling the liquid level. Ambient temperature transmitter is installed around the equipment. In the air moving system, there are sensors installed to achieve the real-time monitoring of the fan driving system, ensuring the safety of the equipment during operation. Those sensors include gearbox oil temperature and oil pressure monitoring sensors, motor starter around resistance and bearing temperature monitoring sensors, and fan vibration monitoring sensor. Automatic control system through the above monitoring data regulates the fan speed of the ACC, and hence it ensures that during different working conditions and ambient temperatures, the back pressure of the steam turbine and/or the subcooling of the condensate are maintained within the setting range.